Good day, sir. I hope you are doing well. My name is Daandre Buiteandag, and I will be presenting my assignment to you today. It's an upgrading of existing gravel road S1066 to a four-lane divided road. Um, on the pledge, it's important thing to note from this slide here. It's in the report, first page on the report there. Then throughout the presentation, I will be taking you through introduction, purposes, project overview, locality, speak about that a little bit, then design standards that I've used, the software that I've chosen, um, pavement structure, design, geometric alignment with Civil 3D, the manual calculations, the Excel calculation tool, the drainage and conceptual design, the design drawings, conclusion and recommendation with just a few references, but the majority will be in the report. So, like discussed, we'll be upgrading an existing gravel road to a four-lane divided carriageway. This is from Bloemfontein, in Bloemfontein, around Bloemfontein. I'm based in Bloemfontein, and that's why I've chosen a more local project for me. The road forms part of the ring road in Bloemfontein, and this you can see it on the spatial development framework. The road is very much in planning phase. A lot of the work has been done. It's not been constructed yet, but like I said, geotechnical, traffic, and a lot of things have been done on this project. So it's very much in the development stage. For this SDF, you can go to the report at Annexure A. It's included there in Annexure A. So the objectives for the assessment is to improve traffic capacity and efficiency, meet future growth and land use requirements, mitigate drainage and environmental controls. And the GI5 competencies is application of design standards, use of software and manual calculations. In this case, for this report, I used Civil 3D CAD. The project overview and locality, we can see, like I've mentioned, it's Bloemfontein, Bainsley, Free State. The road is the S1066. Here I have included the start coordinates and the endpoint coordinates and important key connections. I'll discuss this when you see the start here at R64. This is an important road in Bloemfontein, and it also connects Bloemfontein with Dalesville, Boshoff, and eventually Kimberley. So this is an important connection there. It also connects, yes, the airport, and it's a turn-off there that goes to the airport. So it connects to the airport. There's a venue, Perpetuity Venue and Guest House. It also connects the guest house as well as is a private school that's also been connected to this. Is a very important stretch of road, very busy. So that's why I've chosen it. It's most probably going to be the first road that they will start building for the ring road. The design standards, um, and the design standards and software. So the design of standard references, or the design standards that I've used is the TRH4, geometric design and of rural roads, TRH17, highway drainage design, TRH26 is the pavement drainage design, and the SAPEM, it's the structural design of flexible pavements. The software, like I've mentioned earlier, it's AutoCAD Civil 3D. The reason I've chosen this software is just the familiarity, and lots of people use it in the industry, so I think that's why I use it there. And obviously Microsoft Office, PowerPoint, Word, Excel, and that kind of stuff. So pavement structure design. The traffic loading was calculated at 6.3 million E80s in 20 years with estimated growth projections. All these calculations are in detail in the report, so please refer back to them. The road category B, important rural road, as it will become an important rural road. It's not quite important. It is relatively important, but it's not very important at the moment. Then the CBR data was from GeoCalibre. It's a geotechnical engineering firm here in Bloemfontein. Carl Herbig is the person I've contacted there. You can call him by this number if you want to. Like I said, please refer back to the report for all tables and all calculations here. If you want to. The selected pavement structure is 125 millimeters granular base and 150 cemented sub base. You can see my resignation here. Category B road ES1. It is for the E80s there, and we go for granular cemented. Yeah, like I said, all the other tables, the way I've chosen it is in the report, so please refer back to it. This is just table 19 as a quick summary. Then geometric alignment. Also please refer back to the report. All the Solve 3D snippets and descriptions of what was done in those snippets is in the report, so please go back to that. I'm just going to give a quick overview on this because we only have limited time. So the first step for me was to import the survey points. The survey points was received from Vivian Charles. He's a lecturer at Central University of Technology. You can give him a call on this number. He's a friend of mine. That's why he helped me with this. So please feel free to call him there. Generate contours from the survey points. Contours can be created. It's 1 meter intervals. 1 meter intervals of the natural ground level there. Yes, I kept it on 1 meter. I think that's quite standard. This will be essential for creating the alignment, which is the next step. The horizontal alignment follows the same alignment as the existing gravel road. Now that's an important one for us. It follows the exact same alignment as the existing gravel road. Due to that, the terrain of the road is very straight and very flat. So it's a free state. Everything is quite flat and straight here. So yeah, so that's what we have there. And from that we can create a long section / profile view. The profile view can be created from the alignment and contours. Then the assembly, 4-lane divided road, which is simple. I think we have a 2.5% crossfall with our middleman, and then just a simple drain along the edges of inlets for stormwater. The corridor from the assembly and from the alignments and contours and everything can be created, and subsequent cut and fill volumes can then be calculated, which is very important for when designing a road. So the manual vertical curve calculation, vertical curve, change in elevation, end curve, change in elevation, point of intersection, change in elevation, all was calculated manually. Please refer back to the report. All the calculations is in there. The curve length 150 meters, and then the side distance required 150 at a speed of 80 kilometers an hour. So that's our design speed for the road, and our required side distance is 150. Calculate the K value. Here we have the formula, and we have also the table there. So compliant with standards, the site distance is safe and sufficient. This is once again more in detail in the report. This is just to have an overview of it. Um, the vertical curve satisfies the minimum K value, and the vertical curve is compliant with the minimum length of vertical curves. Then calculation for Excel tool. So I've created this Excel tool here. We can see it. It's just snippets. Oh my goodness, just snippets for vertical curve and also horizontal curve. You can see the PVI change, PVI elevation. This is because we have the change of PC and EC. So this tool can be used to check manual calculations or software values as a method um, to avoid mistakes. Just to double check your work. Benefits, rapid design of multiple curves. You can quickly go on here, pump in your values and have results for it, and it's reusable for other projects. Um, you can see here all the gray blocks are just formulas. You don't have to put it in. I just put it in for this assignment for you to have a reference for how I got to these values there. So drainage design. This is also important, like mentioned earlier. 1.5% is the crossfall towards the edges. Just a simple gutter drain with inlets along the road and at the sides, and so it will flow towards the sides, will flow down towards um, it will flow towards our inlets, and these inlets will flow towards a reserve drainage. So it is proposed that side drains be constructed along parallel to the road. So it will be along the road, like the road goes there, flows into the simple gutter drains, and then along with the parallel with the road until a natural water flow paths where the culverts are implemented. The water drop test was used for this to observe the natural water flow paths. Um, that's how we received, or that's how I got these values for the culvert drainage, culvert change and culvert number. So we have a total of 11 culverts along with the changes where water wants to cross the road. Design drawings, the Civil 3D design drawings, plan views, long sections, all included in the report. Please refer to the report the drawings. I think these are actually B, C, and I think D. The drainage details are also included in the report. The drawing format, project name, north arrow, and date simply quite standard. Conclusion and recommendations. In summary, the S1066 gravel road can be successfully upgraded to a four-lane divided road using appropriate geometric and pavement design standards. Civil 3D was effectively used to generate accurate alignments, profiles, earthwork volumes, and drainage layouts. Manual and Excel-based calculations confirmed vertical curve. Once again, to check what I've received from Civil 3D there. Compliance with site distance requirements and other design standards was successfully met. Pavement design was based on projected traffic loading and available materials, ensuring durability and cost effectiveness. Drainage solutions were integrated to manage surface water and prevent premature pavement failure. For references, this is just a few. A full detailed reference list is in the report. So it's a TRH4, TRH17, TRH26, the SAPEM 2014, and also Civil 3D user guide just for reference and user for to help me with that. Thank you for your attention. I appreciate your time, and thank you very much. This is